Attention, Colonel, I have urgent news. You will be moving up in the ranks if you complete this level of equations boot camp. And this level is about applications for solving equations, which we've been kind of doing all along a little bit here and there within each level, but we're going to do some more specifically word problems in this level. So our goal, our overall learning target is to solve equations from real world problems. A couple things that are important to be successful. Got to know keywords that represent numbers and symbols. Something that we've actually uh, discussed before. We're going to review that. Second bullet point, you got to be able to create equations from the words. So we're taking those words, numbers and symbols, and we're going to put those words, and we're going to put them into numbers and symbols that will form an equation. And the rest is just solving equations based on what we did. Okay, mental check to make sure that it makes sense, and put a label to our answer at the end. So here's an example of what we're going to be doing today. Example like this, where it says, Anne took a taxi home from the airport. The taxi fare was $2.10 per mile, and she gave the driver a tip of $5. And Anne paid a total of $49.10. And the goal would be to write an equation to determine the distance that she traveled, to make that accurate to the total of $49.10. So as we get going there, I want to go over a couple of key terms that might come up. One is, what is a ratio? A ratio is a comparison of two numbers. And the reason I wanted to get into that is because a lot of times in real world situations, we deal with ratios, a specific type of ratio called a rate. A rate is a comparison of two things represented by numbers, usually in fraction form. So two things, not necessarily just two numbers. It could be like miles per hour. So that would be two things, but they're used in they're represented by numbers in a fraction form. And one other type of rate that we're going to be working with is a unit rate. So that's a rate where the denominator is reduced so that the denominator is a 1. Kind of like miles per hour. It's not like you go driving by a uh, a speed limit sign and see that you want to drive 50 miles per 2 hours. You never see that on a sign. But you may see 25 miles per hour, which would be 25 miles per 1 hour. So that's a very common thing that you might see and work with. So let's talk about some key terms um, that would represent these different types of operations or symbols in math. So addition, a key, very important ones. We're not going to talk about every single one that'll fit under addition, but some very common ones would be, um, I think, plus, obviously, increase, more or more than. And I think those are all very common ones, so make sure you have those written down. If we're doing subtraction, you might see the word difference. So the difference between two things. You also might see less than or decreased. Now, division is a little bit tricky. We don't really use division a lot, so the word divided by or divided up would be a very common one. And we're gonna leave it at that for right now, unless one other comes to mind. Very common for multiplication, though. Multiplication, the word per. So miles per hour. Um, and I'm gonna put per over division too, but now we're gonna leave it as multiplication for our sake. But more often than not, oops, more often than not, per is going to be representing multiplication. So is each, the word each. All right. And lastly, equals. Where are you going to find an equal sign? Well, that would be if you had the word total, or is, or equals. Those are all words for equals. So make sure you have those written down. If you don't, please do so. So let's go to our first example. I'm only going to go through maybe 2 or 3 examples because there's so many different types of examples. We're just going to try to get more and more practice, but I'll give you a few here. Here's our first one. It says, since starting a new recycling plan, Phillips office recycles 3 kilograms of paper each week. So that we have a 3. I'm going to circle the numbers and each. How many weeks will it take Phillips to office to recycle a total of 12 kilograms? Now, by the way, it's always important to figure out what the variable is, and this time we're trying to find how many weeks. So let's just say W. And let's just go in order, see if it works in order. Phillips office recycles 3 kilograms of paper each week. So each we said oftentimes is multiplication. So let's say 3 each week, 3W. And then how many weeks will it take Phillips office to recycle a total, so equals 12. Now that's it. There's no other information given. So we're just going to leave it at that. 3W equals 12. I hope you know how to solve this. It would be with the inverse of multiplication, which is division. And you end up getting W equals 4. Now, what does that mean for the situation? It's asking how many weeks, so we'd say 4 weeks total. And you can do a mental check. 3 kilograms for 1 week, 6 for 2, 9 for 3, 12 for 4. There you go, 4 weeks. All right, let's try the second one that I showed at the beginning. It says, Anne took a taxi home from the airport. The taxi fare was we got a number. $2.10 per, that usually is multiplication, mile. So $2.10 per mile. And she gave the driver a tip of $5 and paid a total of $49.10. I do want to point out one other word for addition. And is another common one. Depending on how it's used, it sometimes can be for addition. Now the question is, write an equation to determine the distance in miles. So miles is what we're trying to find. So we'll use X for that. Per mile. Oh, there we go. Between the airport and Anne's home. So let's just go in order, because a lot of times it'll work in order with the way it's read. Taxi fare was $2.10. So I'm going to put 210. Per is multiplication mile, and mile is X, what we're trying to find. So $2.10 times X. And she gave the tip of $5. So it doesn't matter how many miles it went. She just gave a tip of $5 that we're going to add to that to get the total of, because total, 49.10. No other information is given. That's all we have. Let's solve it and see if it makes sense. So I'm going to do first inverse operation, what's not attached to the x. So minus 5 here to get rid of the plus 5. Minus 5 here. So when you bring that down, we have 210 x equals 4410. And then our last inverse operation would be dividing by 210 on both sides. So I get x all alone. I'm going to pull up the calculator. Don't quote me. I think it's 21 because I did this one before. But if I do 4410, 44.1 or 10, divided by 210, $2.10, I get 21. There it is. Now, what does that mean for this situation? It says write an equation to determine the miles. So x is our miles. So that means she went 21 miles. And you can check that by doing 21 times 210, because it's 210 per mile, and then adding 5 at the end. And you do get 49.10. Let's do one more. This one actually comes from the homework for this section. Last one, it says, Mary bought a magazine for $5 and 4 erasers. So I'm going to just circle a couple things. A magazine was $5 and 4, it's not written out as a number 4, but it's 4 erasers. She spent a total of $25. Write and solve an equation to determine how many of each eraser costs. So we're trying to figure out based on erasers cost. So let's say that's our x. So x is erasers. Now I am going to use a different color because that doesn't seem to be working too well. Let's write it out in order once again, see if it works. $5, about a $5 magazine no matter what. Plus 4 erasers, which we don't know how much the erasers cost, so we're going to add 4 times however much the eraser costs. And a total of $25. So let's solve it and see if this makes sense in the end. Minus 5 from both sides, because that's still what's not attached to the variable. So we have 4x equals 20, just 20. Divide by 4, and you end up with x equals 5. And that's dealing with the eraser cost. So how much does each eraser cost? $5 for an eraser? Where the heck are we buying erasers from? Let's just double check to make sure that makes sense. If there's 4 erasers that are $5 each, that would be $20. And then an extra $5 for the magazine, that would be a total of $25. So these must be really, really super good erasers if we're spending $5 on each eraser. But it checks out. It makes sense with the problem. We did a mental check there. So that's just our review of applications for solving equations. Going over that learning target of solving equations from real-world problems. We did these success criteria, and I think if you follow those and you use those key terms, you'll find that you will be successful in writing equations and solving for real-world applications. All right, Colonel, move on up in the ranks. It's time to crush it. We'll see you later.